Today we are going to be talking about exponents and specifically zero and negative exponents. To begin, we need to understand what the exponents represent. So in a power, that's where we have a base and an exponent together, that's called a power. Powers represent repeated multiplication. The base is the number that's multiplied by itself. The exponent is telling us how many times the base is multiplied by itself. So for example, with the expression 2 to the fifth power, 2 is the base. That's what's going to be multiplied by itself. 5 is how many times we multiply it by itself. So 2 to the fifth power is 2 times 2 times 2 times 2 times 2. And when we evaluate that, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again, we get 32. Then 2 to the fourth power means we're going to multiply 2 by itself 4 times. So 2 times 2 is 4, and then times 2 is 8, times 2 again is 16. 2 cubed, 2 to the third power, or 2 cubed, is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Evaluating 2 to the second power, or 2 squared, is 2 times 2, which we all know is 4. All right, and then 2 to the first power, one factor of 2 is just 2. Now, when we're thinking about 2 to the 0 power, a lot of students might think that that would equal 0. But let's first look for a pattern in what we've already seen and then use that pattern to predict what the next number will be here. So to go from 2 to 16 to 8 to 4 to 2, you may notice that each time as we go down this table, we are dividing by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So if that is our pattern, every time we decrease the exponent by 1, we have one less factor of 2. So we're dividing by 2. When you take away a factor of 2, you're dividing by 2. 2 divided by 2 would equal 1. So in fact, 2 to the 0 power equals 1 because it's like taking 2 divided by 2. And then if we continue that pattern, dividing by 2 again, 1 divided by 2 is 1/2. Divide by 2 again, dividing by 2 is the same as multiplying by a half. So when we take half times a half, we would get 1/4. Dividing by 2, the same as multiplying by a half, we would get 1/8. And then dividing by 2 again, we would get 1/16. So note that 2 to the fourth power is 16, but 2 to the negative 4 is 1/16. It's the reciprocal. And 2 to the negative 1 is the reciprocal of 2 to the positive 1. 2 to the negative 2 is the reciprocal of 2 to the positive 2. So if the exponent was positive 2, it's 4, but if it's negative 2, it's 1/4. So that's to summarize that, as the exponent decreases by 1, the power is divided by 2. If an exponent tells us how many times to multiply by the base, a negative exponent, what would a negative exponent mean? So how can I multiply by a number a negative 3 times? So it's like, what's unmultiplying? That would be dividing. So negative exponents are actually telling you to divide by that base. Another way to divide is multiply by the reciprocal. So that's why we saw those reciprocals with the negative exponents. So any number that's not 0 raised to the 0 power equals 1. And when we have a number to a negative exponent, that's our reciprocal, 1 over that number to the positive exponent. If the negative exponent was in the denominator, the reciprocal would be in the numerator. So for example, in number 1, 5 to the 0 power, that would be like taking 5 divided by 5, which equals 1. 3 to the negative 1 means the reciprocal of 3, so 1 over 3. Here we've got some variables. We're assuming those variables are not 0, and when those are raised to the 0 power, that equals 1. When we take a look here, 12 it has an exponent of an understood 1, so we wouldn't change anything about that. But x to the negative 5 would be equal to 1 over x to the 5th, and then y to the 0 power equals 1. So that gives us 12 over x to the 5th. Now, in example 5, we're dividing. First, we want to divide the coefficients. 28 divided by 7 gives us 4. And then wherever you have more power, so we have 5 factors of x in the numerator, 12 factors of x in the denominator. 12 is bigger than 5, so we would take the difference, 12 minus 5, in the denominator. So 4 over x to the 7th. In number 6, 16 divided by 8 is 2. When we're dividing powers with the same base, we keep the base and subtract the exponents. 5 minus 5 is 0, and then keeping the base and subtracting the exponents, we'd have x to the 6 minus 3. So we get 2, y to the 0, x to the 3rd. Anything to the 0 power equals 1. So it's like 2 times 1, which would just be 2. So 2x cubed. In number 7, we would divide our coefficients, 72 divided by 9, and then if it has a negative exponent in the denominator, we do the reciprocal, so we move it up to the numerator, and it would become positive. This y with the negative exponent in the denominator, we'd have to do the reciprocal and make the exponent positive, and then 2 to the negative 3 with a negative exponent in the numerator, we'd move it to the denominator. So it's going to look like this. Y to the 7th over 2 cubed x to the 5th. X to the 5th already had a positive exponent, so we would just keep that in the denominator. And then we can evaluate 2 cubed. That's 2 times 2 times 2, which is 8. And lastly, we've got some like bases here that we're dividing by. X to the 5th divided by x to the negative 2. Remember, the rule is keep the base and subtract the exponents. So it'd be x to the 5 minus negative 2. And then same with y's, dividing parts with the same base, keep the base, subtract the exponents. 5 minus negative 2 gives us 7, and negative 3 minus negative 8 gives us 5.